So my basic question you talked about is, you said that the graphs, right? So if you rewind 2 years back, everything was like, pulling the data here and then and presenting it. Then came the no code, low code tools. You can pull and you can add, connect, configure every database and then pull and then manipulate, transform the data and then look at it. Now you are saying AI is imbibed, right? You are telling on top of graph how the recommendation happens with this AI. So to my audience, let's think everyone are dumb. They do not know anything about AI. So what is making between the AI and the graphs? What is that? Is it a model? Is it a same like a database? Or what exactly I can understand as a layman? What exactly is added there?
Okay. Let's understand fundamentals of AI. And I think everyone knows the definition. So you all know that AI means artificial intelligence, right? Which means is like what it mimic the human cognition, means like human knowledge. So it's like when any system which mimics the human behavior or a knowledge or a patterns, that's call it as a AI system. So if you're looking at graphs, right, what we embedded, so it's like once, because as I said earlier, so data science means is like a three building blocks. That's a block box. They say that data engineering, data modeling, then data visualization, which you call it as the graphs, which you said that is a third block. So the problem here is understanding. It takes time. So that's where I wanted an easy manner. So let's talk about in a manufacturing sector. So it's like a 24/7 machines are working. So the one project which I used to work, and now also we are working on one of the project called sheet break prediction. So it's like a paper manufacturing. The paper is continuously rolling. So if you're looking at a paper per minute is 1,500 meters it revolves. And the biggest challenge here is compared to the predictive maintenance of manufacturing and the paper is completely different, because there, if any problem, machine stops. So we have some indication. Here is not the same case, because the machines will be running, but paper will be cracked. The roll, the paper is a scratch. So here, if you're looking at it, the fast speed, the lightning speed is moving it. So when I'm showing the graph, I can't understand. It takes time. By the time there is something has happened. So what I wanted to use it. So we wanted to use the same thing, a human way of it. So what human does, so they go and physically monitor it, but it's practically also impossible. So what we did is like we used the same AI, means like a Gen AI, which we call it as. So it see the patterns of the graphs, because when manually, if you are understanding the graph, it's a time consuming, it's a difficult to understand. That's where we use a Gen AI and the behind. So we run LLMs, so the large models, right? So we use LLMs. It tries to understand the patterns, and it derives the recommendations, which means is like a one-line tag sentences. So these the tagline sentences like so and so time, so and so going to happen it, and so and so factors. So we extract that kind of recommendations, and we try to send it to WhatsApp, SMS, and email, three forms. So we use AI to understand the graphs and in a readable format. Then we send it in a text format. So it's just like if you're looking at a speech to a text conversion. Same here, what we are doing is visual to visual semantic representation. From visual to, we are extracting the semantics.
Excellent. Now, at least we got a perspective and an example what you have shown.